quantities are there in current electricity. Those are potential or electric potential, current and resistance. And their relation we will discuss. Okay, so first fundamental quantity of this chapter, let us discuss about current. We will discuss about current. Okay, so what is current? Current can be defined as the rate of flow of charges. Current can be defined as the rate of flow of charges. So here question arises, we have two type of charges. One will be positive charge, another one will be negative charge. Then which charge it moves? So it is the electron, they move. So here also we can say this is flow of electrons also. So what we can write in so other words, current flowing conductor, it is the amount of charge flowing per second across any cross section of it, that is known as current. So current, it is represented as I, and here rate of flow of charges, charge can be represented as Q, and as the word rate of flow, when we talk about rate is always with respect to time. So here we are getting I equal to Q by T. Here what will be then unit? So unit of current, here Q stands for unit of charge is coulomb. COU coulomb. And here this one is second. Otherwise this name is coulomb per second, otherwise can be it is ampere. So unit of current is ampere. Unit of current is ampere. So 1 ampere of current can be defined as 1 coulomb by 1 second. So when 1 coulomb of charge flows through a conductor in 1 second, then the current flowing through it is said to be 1 ampere. Clear? So here also another part is there. 1 coulomb of charge, it consists of 6.25 into 10 to the power 18 number of electrons. So otherwise we can say, so this 6.25 into 10 to the power 18 number of electrons flows through a conductor for 1 second. Then this current is said to be 1 ampere. Here also we can represent this I equal to, we got Q by T. So as it is Q equal to N number of electrons, that is why Ne by T also it can be represented. Understood? So here current, it is a scalar quantity. Current is a scalar quantity. This one, it is a real confusion for the students, because we know in current, when current flows, the number of charges they flow. But one thing is that whenever there is a flow of current, we have two type of current. One will be conventional current, another one is your electronic current. And okay, so one is conventional current, another one is electronic current. This electronic current is the flow of electrons. This electronic current always flow from the negative potentials towards the positive potential. Okay, here always electronic current flows from high concentration of electron to low concentration of electron. As cathode, it is the bank of electron, then we can say that this electronic current flows from this negative to positive terminal. So what is conventional current? This conventional current always flow from positive terminal to the negative terminal. Flows. Okay, so here what we are getting, this flow of current and flow of electron are always opposite to each other. Direction is always opposite to each other. Understood this? So here question arises, why we are getting current, and that too current, it has direction, it has magnitude, current has magnitude, but we cannot say this current is the vector quantity, because this through a cross section area, if we are taking this conductor or a wire, we are taking, okay, let it be this one, and if electrons flows this side, current flows this side. How many electrons pass, that much electrons they enter. This is the reason only why current cannot be considered as the vector quantity, rather current considered as the scalar quantity. Okay, and here there are some units, the smaller units or weak current, which are the weak current, those can be represented as the milliampere. Milli means what? 10 to the power minus 3 ampere. And microampere also, micro is 10 to the power minus 6. It is also weak current, milliampere. Then otherwise it is micro. This one it is microampere. So it can be 10 to the power minus 6 ampere. Okay, so all these are the concept of this current. Then we will go for electric potential. This is another interesting. Let us go for it. Electric potential. Electric potential. So first of all, let us see what is electric potential. Here, to get this confusion, to overcome this confusion, let us see. Let us take a electric field. Let this one is the electric field. Okay, this one it is the electric field. And here we know that magnetic field is due to magnet. So here let us see. Let us have the magnetic field is due to presence of a magnet. Now my question is that this, if I am talking about a electric field, this electric field is due to what? Whether it is a current, whether it is a charge or what. Here many children, when question is asked, many children they answer it is due to the current. No, it is not due to the current, it is due to the charge. Okay, here due to the charge. So magnetic field is due to magnet and electric field due to the charge. Now let us take a unit positive charge. A unit positive charge I am taking. Positive charge, unit positive charge. Okay, this unit positive charge is at a point A. I want to bring this unit positive charge to this point B. Automatically from point A to point B it will not come. It will come. No. So some force have to apply on this charge, or let it be pushed, let it be attracted, whatever, something, some force have to apply on this unit positive charge so that it will come from A to B. What is the distance it has moved? Let it be distance as it moves. So what we are getting? We are getting forces applied on the body. We are getting forces applied on the body, and there is some displacement. There is some displacement. Two factors I am getting. What does it give us? It gives us work done. It gives us work done. And whatever work done is equal to energy spent. Remember this one. Whatever work done equal to energy spent. Now let us go for the definition of electric potential. Let me first of all tell you, then we will go for this electric potential. So potential at a point can be defined as the amount of work done per unit charge. This unit charge, the amount of work done in bringing the unit positive charge from infinity, we don't know at what point it is, from infinity to a point, to a particular point. Okay, that is known as, I told this one, it is electric potential. Definition of electric potential. The electric potential at a point is defined as the amount of work done in bringing a unit positive charge from infinity to that point within that electric field. Okay, here also we can say the electric potential at a point can be defined as the amount of work done or energy spent. It can be energy spent also, because whatever work done, that much equal to your energy spent in bringing a unit positive charge from infinity to that point. Okay, and here electric potential, it is denoted by V. So let us see what will be its formula for it. So potential electric potential, what I told, that is the amount of work done by whom, by a charge. Okay, that's why you can write Q, otherwise you can write small q also. So what can be represented? V equal to W by Q. Okay, so what will be its unit? Its unit, work done equal to joule, energy spent equal to joule, divided by charge equal to coulomb. So this also can be represented as volt. So usually some question is asked usually to the students at the class, what is name the physical quantity whose unit is joule per coulomb. So all of a sudden students, they used to give answer, it is volt. Do you think volt is a correct answer? No. It is not the physical quantity. Volt is a unit. So your physical quantity is electric potential, or we can say potential. Understood? So this is also a scalar quantity. Okay, and here this is very interesting. This electric potential, it is that that physical quantity which determines the direction of flow of current. So electric potential, this is important. Electric potential is that physical quantity which determines the direction of flow, of current. Which, this one it is important. Direction of flow of current is important, because we know current flows from positive terminal to the negative terminal. We know that one. But here, if we are connecting two positive points, one will be, let it be having 10 units. It is connected to another one. Which of these 5 units or 5 volt? One will be, let it be 10 volt, another will be 5 volt. Which will be the direction of flow of current? Flow of current will be from the positive to the negative terminal. Sorry, to the higher potential to the lower potential. So here this is the electric potential only, which will tell you this direction of flow of current. Understood this one? And here also another part is some relation here we can say, as this temperature, hotness or coldness of the body. If a hot body, it is in contact with a cold body. Okay. So if both are in contact with each other, after some times we see that one, this temperature of hot body down and temperature of cold body, it is. So here that is the flow of heat. Heat flows from hot body to the cold body. This is similarly if we are connecting two containers having water. Okay, here it will be like this. Here another it will be same. We will take connected to each other. One will be at higher level, another one will be at lower level. So flow of water flows from higher level to the lower level. All these are the relations, means all this can be related to each other. So here current flows from high potential to low potential, heat flows from high temperature to low temperature, water flows from high level to the low level. Clear? So here what we can go for then, here to define 1 volt. So here 1 volt equal to 1 joule by 1 coulomb. Yes. So what we can write here? So 1 joule of work is done. 1 joule of work is done in bringing 1 coulomb of positive charge from infinity to a point. Infinity to a point in an electric field. Okay, so this one will be your the definition of 1 volt. We said to bringing in positive charge, 1 joule work is done with positive charge in an electric field. Then the potential is said to be 1 volt. Nothing I have done, only rearrange the words. Okay, joule of work, here the joule of work is done by bringing a unit positive charge. This is the unit positive charge from infinity, because we had discussed if this is the electric field, here unit positive charge I have kept. From infinity I have to bring it to point A, let it be point B. Clear? Within this, then the potential is said to be 1 volt. The same thing only I have taken, only rearrange the words. Clear? Then we will go for what is the potential difference. The same thing only potential difference. Potential difference always consider between two terminals. Within that electric field, let it be. If I am talking about here, let it be A, let it be B. So here whatever this difference in the two terminals of this potential, that is known as potential difference. So what we can say here, this V, let it be BA minus BB. I will tell you here what is AB. For example, this one only we have discussed, let it be A, let it be B. So difference in the potential. So what we can write? Work done A by the unit positive charge Q by work done by B by unit positive charge Q. So which one? If VB is greater, then it can be WB by Q minus WA by Q. Which one is greater? That one will be the first. Second one, which is the value is less, can be subtracted. This is your potential difference. And here this potential difference is measured by this potential difference, or electric potential also can be measured by voltmeter. And this voltmeter is connected parallel to the circuit. Remember this one, voltmeter can be connected parallel to the circuit. Now Ohm's law. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across its ends, provided the physical conditions and the temperature of the conductor remains constant. Okay, so here this one, it is very important. Here when this question comes, write Ohm's law. So children, they used to write directly proportional to the difference between its potential potential difference across its ends. This much only they used to write. They don't write this much. That is why they lose marks. So now if I have written this one, what I will write here, let me go for this mathematical value for it. So current flowing, current represented as I is directly proportional to V. Okay, so if current is directly proportional to potential difference, it means that potential difference increases, current increases. So I can represent V is directly proportional to I. Clear? But for a long time I cannot keep this proportionality symbol. So I have to remove this one. So what I can write? V equal to I R. Okay, this one it is the Ohm's law formula. What is R then? R equal to resistance. R is the resistance. R is the resistance of this conductor. Okay, I will tell you what is resistance. So R is the resistance of this conductor. So we got V equal to IR. V equal to IR. So what I am getting? I equal to V by R. I equal to V by R. So what is the purpose of writing this one? It represents that I is directly proportional to V and I is inversely proportional to R. Here, this meaning of this statement is that here potential difference or electric potential increases, then current increases. If it is increases by 2 times, it also increases by 2 times. Okay, here increases. Then what is the relation between this I and R? So here current increases. So rather instead of writing current increases, let us write resistance increases, current decreases, and vice versa. If resistance increases 2 times, current decreases, means this one will be, current will become half. If resistance increases 2 times, current will become half. Clear? Then another important is that when we are discussing Ohm's law, V equal to IR, this is the most fundamental law and formula. Wherever we will discuss how many numericals we will discuss, depending upon this V equal to IR formula only we will discuss. So remember this formula, V equal to IR formula. Okay, clear? Then I will go for what is the limitations of Ohm's law. This one it is important for us. Limitation of Ohm's law. What is the limitation of Ohm's law? First of all, it is said in the this law itself. It is said in that in the law it is said temperature has to be constant. So law is that temperature of conductor should be same or it will be constant. Temperature should be constant. Second one, what is that one? Here, this should be a conductor. Here, this one, this whatever conductor we are taking, that is ohmic conductor, or this should be a conductor or metal we can say. Third one, it should be of, this conductor should be of uniform cross section area. These are the limitations of Ohm's law. Okay, so these are the limitation of Ohm's law. So now we will go for what is the graph it is represented by Ohm's law. It is a graph represented by Ohm's law. So here let us see what is the slope of this graph. Let us see. So here what it is we are taking, this one let it be V, this one let it be R. So let it be I. And we have two type of conductors. One is ohmic conductor. Second one is non-ohmic conductor. One is ohmic conductor, second one is non-ohmic conductor. What is ohmic conductor? Obeys Ohm's law. It obeys Ohm's law. And what is non-ohmic conductor? It does not obey Ohm's law. Understood? What is obeys and does not obey? Obey means that here V is directly proportional to I. This is Ohm's law. If some conductor obeys this one, then only it will be this ohmic conductor. If it does not obey, then this one will be non-ohmic conductor. Clear? So here let us take VI graph. In this case, VI graph, this for ohmic conductor, the graph is always a straight line. Not necessary that it will start from this from here in the origin. It can be also from here also it can be, but whatever it may be, it should be a straight line. Clear? But in case of non-ohmic conductor, if I am taking this same graph, I will take V and I graph. This non-ohmic conductor can be, it is not a straight line. It can be like this, it can be like this. So, which shows that one up to some extent it obeys Ohm's law. After that one it does not obey Ohm's law. So this is non-ohmic. This one let it be 1, let it be 2. This graph is for 1, this graph is for 2. This one for ohmic conductor. So this one, as it is directly proportional law, so this voltage goes on increasing, current also increases. Here for some view it will be for some time, it will be increases, after that it decreases, or after that again more also it can increase. So that is your ohmic and non-ohmic conductor. Clear? Then here let us see that one. What is the slope of ohmic conductor give? So let me rub this one. Let us go for this ohmic conductor only. Okay. So in case of ohmic conductor, it obeys Ohm's law. We have discussed. Now let us take. Okay. Look straight now. Okay. Now let us take a point from here. This is a point A. Let us draw a perpendicular to x-axis, perpendicular to y-axis. Understood? So here let it be A. This one is B. This one is C. This one is O. Let us take the slope. So slope here, slope is AB by OB. Then here what is AB? AB is equal to OC. Here OB will remain same. What is OC? Value is OC. OC represent V. What is the value of OB? OB represent I. Clear? Then let us, this one will be for us, and it gives the value of the resistance. This is resistance or R. So how to remember this one? We have formula B equal to IR. Here from here what I am getting? R equal to V by I. This one we are getting. Here we are getting. So slope of VI graph, it gives resistance. Remember this one. So usually confusion for the students, whether in x-axis we will put V or we will put I. This also I can put a V, this also I can put I. But here the instead of value resistance, we will get something else. When we will discuss, we will get that one. That is known as here resistance, that is known as conductance. Clear? So here, so we can write the slope of VI graph gives resistance. VI graph gives resistance. Okay, so this much only you remember for the time being. When we will proceed all about this resistance, after that automatically we will get more things for it. Okay, so now if I am talking about resistance, let me talk about conductance also, so that when I will discuss, I can discuss more and I will give the definition of resistance. So here, um, uh, what is resistance? Resistance is nothing but the obstruction offered by this substance. Means when the flow of current will be there, so this is the let it be that wire through which current flows. Okay, so what happens? These electrons, they flow. When they are flowing, from where we are getting these electrons? We are getting, let it be the copper wire I take this one, it will be a copper wire. If these electrons I am getting from one atom of copper, so we know copper, it will lose 2 electron and copper 2 plus will be there. Yes, like that many 2 plus ions will be there. So here let it be, I represent this one as positive. So electrons, when electrons are flowing, these positive charge particles, they give the obstruction to the flow of electrons. This is nothing but resistance, and resistance is offered by resistance in a conductor is offered by positive particle particles, or it can be your positive ions and the atoms, because all the atoms, they do not become ions to lose electron. Many will be there in that atomic form. So resistance is offered by whom? Is offered by the positive charge particle in the atom itself. Means this flow of current is get obstruction. Means electrons, when they are flowing, they are colliding with somebody else. Who are this somebody else? These ions, positive ions and the atoms. Clear? So now comes the definition of resistance. It is the property of conductor by virtue of which it opposes the flow of current through it. Means the flow of current, when the current flows, somebody opposes its motion. That is known as resistance. This is the one of the property of the conductor. Each conductor acts as a resistor. Okay, so here what we can say, resistance, here we have discussed already, resistance in the conductor is offered by these particles or positive charge particle and the atom itself. So this has the flow of this resistance is offered to the flow of electrons. So when in a conductor these electrons are flowing, those are offered by this positive charge particle, they collide with them. So which one, the direction they are moving, they cannot move. So now from this Ohm's law formula, V equal to IR formula for us. So what we are getting? R equal to V by I. So what will be the unit? Unit will be volt by ampere. It can be, so it can be V by A, volt by ampere. But this unit, we don't usually, children, they don't prefer to write volt by ampere. Unit of resistance is ohm. Resistance is ohm, and it is represented by symbolical representation will be like this. Clear? So if we are discussing about resistance, let us go for this conductance also, then we will go for factors affecting resistance. So here what will be conductance? What will be conductance? So conductance is the reciprocal of resistance. Conductance is reciprocal of resistance. Okay, so here we can write conductance is equal to 1 by resistance. So here it implies more will be conductance, more will be resistance, less will be conductance. More will be conductance, less will be the resistance. Okay, and here the unit of ohm is, so it is represented. What is its unit? So as it is ohm inverse, so we can write it is ohm inverse, otherwise it can be -1 like this can be written, or usually that one is 0, and it is denoted by S. Got it? Now let me go for the part, another part for it. I have told you. Okay, understood, I hope. Then I will show you another part. Here, let me take two graphs. This is the same thing only. Here I have taken V. This one will be I. I am taking I. I am taking this one V. Clear? This is the same thing only taken. Physical quantities have same, but just only interchange. Now, this one will be because I am considering Ohm's law. See children, this one will be a straight line only. Okay. This one is a straight line. Now, let us draw a slope here. Slope here. This one will be slope here. What does the slope of VI graph, and this one is the slope of IV graph. So when question comes in that exam, see that one what is in x-axis and y-axis given. Here we know from the VI graph what we are getting. This one is resistance. But here what we are getting? Slope is equal to here O, A, B, C. So it is AB by OB. AB equal to OC by OB is equal to OC equal to I by V. What is I by V? What is I by V? So I by V is nothing but 1 by R. If you don't remember this one, remember V equal to IR. I am getting I by V. So here I by V. So what I am getting? 1 by R. So this one is 1 by R, which is related here. So now we have discussed what is 1 by R. 1 by R is conductance. Conductance. Okay. So this slope of VI graph gives resistance and slope of IV graphs gives conductance. Clear? Now we will go for factors affecting resistance. This one class 9th we have read it. Still let us go for it. So factors affecting resistance. Okay. So whenever we are talking about factors affecting resistance, first factor will be always depends upon material, depends upon the material of the body. Okay, it depends upon the material or nature. The nature of the conductor. Nature of the conductor. Okay, so what is this nature or material of the conductor? Here some of these conductors are more, means conductance is more because they offer less resistance, and some of these conductors they offer more resistance and conductance is less. So some conductors offers more resistance, some offers less resistance. Okay, who offers more resistance? Obviously for them conductance will be less. Those who offers less resistance, for them conductance will be more. Clear? Then let me go for the second part. Second is it is resistance is directly proportional to the length of the conductor. Length of the conductor. Obviously, this one will be the small length I am taking. This one will be the more length I have taken. Okay, so electrons are flowing, positive charge will be there, atom will be there. When they are flowing, upper resistance upward will be less in this case. Here, long distance have to move these electrons. So obviously, there will be more this positive charge and these atoms, everything have to come across. That is why this more will be the length, more will be the resistance for this. So what we can represent here, L is directly proportional to R is directly proportional to length. So I can represent one formula for it. R1 by R2 is equal to this one will be L1 by L2. Okay, R1 by R2 equal to L1 by L2. This is the length of this conductor. Okay, you write down this one. Then I will go for this. Okay, the third part we will discuss. Third one, it is inversely proportional. Third one, it is inversely proportional to the area of cross section. Area of cross section. So R is inversely proportional to area. What I can represent? I can represent R is inversely proportional to A. Means if I am taking this one is the thicker wire and I am taking this one having the same length, if length will be same, but I am talking about thicker some wire and this one is the thinner wire, in which case resistance will be more. Thinner is the wire, this one will be R is more, this one is R is less. This is the relation. It is more is the area, less will be the resistance. Less will be the area, more will be the resistance. Clear? So what I can represent here, R1 by R2 equal to A2 by A1. All these are the we can make formula for it. Clear? Then another important for us is fourth one. It is directly related to directly proportional to the temperature. Directly proportional to the temperature. So R is directly proportional to the temperature. More is the temperature, more is the resistance. Clear? So what happens? One concept, simple concept for is here, when temperature will be more, if I am taking this one is the this conductor, temperature more, obviously this kinetic energy of these particles will be more or not. So when kinetic energy of the more of the particles is more, vibration is more, obviously therefore more resistance to the flow of this current, flow of this electron. Okay, so we will combine all this and we will go for a formula for it. So what is that? So here R is directly proportional to L, inversely proportional to A. Okay, so what we can write? This directly proportional symbol we cannot keep for a long time, so we have to remove this one. So R equal to this some cases you can take area A, small a, or capital also A also it can be taken. There should not be any confusion for it. This represent for this. Okay, so here it tells that one, if length becomes twice, resistance becomes twice. Area becomes twice, resistance becomes half. Okay, so here let me go for, so area is sorry So R is equal to rho L by A. So rho, it is specific resistance. Rho is specific resistance. Clear? So all this one is the formula. We can go for it. Here, if we will see this, okay, got it? Now let me go for it. Here, one formula, let us combining formula. R1 by R2 is equal to L1, L2, A2, A1. So here length increases, or length, this one is the initial length, final area, initial area. Okay, you remember this formula. Depending upon this one, many numericals to solve. There are many numericals we can solve using this formula. Okay, then we have come across these factors we have discussed. Then we got one thing, that one will be only specific resistance. Okay, this specific resistance, what we got, R equal to rho L by A. And if we will talk about rho equal to R A by L. So what will be the unit of rho? Is equal to R. This one will be ohm. A, this one will be meter square. L, this one will be meter. So what we are getting? Rho equal to ohm meter. It is ohm meter. Okay, so here also we can represent ohm meter. And one important thing is that here this specific resistance of the body, it does not depend upon the shape and size of the body. Here most important is that here specific resistance factors. Okay, factors depend upon this specific resistance. On which specific resistance depend on? It is characteristics, property of the body or material of the body. Here material of the body. Second one, it is depends upon temperature. Okay, so it is how it is depend upon the temperature. It is directly related, directly proportional also, directly proportional. Okay, so here if the specific resistance increases with increase in the temperature, in case of metals. So let us write that one. In case of metal, specific resistance, let me write this one like this. Okay, this rho, symbolically let us write out this rho increases with increase in temperature in case of metal. But here let it be for the semiconductors. Semiconductors, it is decreases with increase in temperature. Okay, so semiconductor, example of semiconductor, what it can be? The semiconductor, it can be some alloys also, it can be example, it can be alloys, it can be sorry. So semiconductor, it is this one, but for alloys, okay, here, sorry, this one it is for alloys, this one it is remains constant. Rho remains rho remains constant for alloys. Okay, so here with the remains constant with change with change in temperature. Change in temperature. Okay, so the specific resistance factors affecting it, it depends upon the material of the body or material of the conductor. Material of the conductor. What type of conductor you are taking, and it is different for different substances. It is very low for the metals, and alloy it is different for the semiconductors, it is different, and it depends upon the temperature. It is directly proportional to the metals. To the metals it is directly proportional. Rho means specific resistance increases with increase in temperature for metals. For semiconductors it is decreases, and for alloys its rho remains constant. Clear? And it does not depend, this big letters let me write, does not depend on shape and size of the body or conductor. This is most important. Clear? So this does not depend on the shape and size of the conductor. So question comes for us, the length of conductor becomes twice. Okay, length of the conductor it becomes twice. So how this how does the resistance between specific resistance vary? Okay, length of the conductors becomes twice, so resistance it becomes twice. But in case of specific resistance, no change. That one will be no change. This one is important. Usually question comes for this. So other name of specific resistance is resistivity. Okay, so if we have discussed resistance, conductance. Conductance is reciprocal of resistance. Now we have discussed resistivity. Now let us discuss conductivity. So conductivity is the reciprocal of specific resistance or resistivity. So this conductivity it is represented by sigma. So sigma is equal to 1 by rho. Okay, so rho equal to what we have discussed, R equal to rho L by A implies R A by L equal to rho. So now 1 by rho equal to how much? L by R. Okay, so what will be its unit? So its unit can be can be centimeter per meter or ohm inverse, meter inverse. It can be like this. So unit can be ohm inverse, meter inverse. Now one question for you, try to answer. I have given you a graph. This is VI graph I have given, and this y-axis represent potential and I represent current, which is given in the x-axis, and AB are two conductors. Okay, so here we have to answer these questions. Whose resistance is more? How to find out whose resistance is more? To find out resistance more, whose slope will be more, that resistance will be more. So here we can write more slope more slope, more resistance. Yes or no? So how to find out this slope? So to find out the slope, let it be a point we are taking from here. Okay. So in this case, for B, let it be P, Q, R. And here also we will give okay. So here for A, the slope will be P by R by OR. For B, slope will be QR by OR. Yes. So for both A and B, OR will be constant. For whom this voltage will be more, resistance will be more for it. So for A, slope will be more. That is why answer will be A. I hope you understand this one. What will be? So for A, slope will be more. How to know this slope will be more for this case? Here, let us have for A, slope will be P by R divided by OR. For B, slope will be QR divided by OR. So here, PR is greater than QR. Understood? That is why slope will be more. So, slope of A is greater than slope of B. Yes or no? Okay. So, as slope will be more, then this resistance will be more. That is why whose resistance will be maximum now? Resistance of A will be maximum. Then whose length is less? Length is directly proportional to resistance, or resistance is directly proportional to length. So here whose resistance will be less, then its length will be less. Resistance whose it is less, for B resistance less, so it is length for B will be less. Understood? Which is thicker? Thicker means thicker, it is inversely proportional. R inversely proportional to A. Are inversely proportional to A. So what to do here? If I am considering this one will be, it is as thicker. Which one it is thicker? If thick, it will be less resistance. Whose resistance is less? For B, resistance will be less. Do you understand this one? So here thicker, this one will be less resistance. Less resistance for whom? For B will be less resistance. Got? Which is at high temperature. Temperature is directly proportional to temperature is directly proportional to resistance, or resistance directly proportional to temperature. Whose resistance more? Temperature will be more. So in case of A, that one will be at high temperature. Sorry, high resistance. High resistance means high temperature. Clear? Then whose conductivity is more? Sorry, not conductivity, conductance. Here it is conductance. Is conductance is more. So conductance is inversely proportional to resistance, or inversely proportional to conductance. So whose it is more? So more conductance, less resistance. Whose resistance will be less? B resistance will be less. Okay, so this one will be, check your answers. Out of 5, how much you got? Clear? So this is all about this. So now little I will reverse this one. In place of V, I will write I, and in place of I will write V. So in this case, entirely whatever we had discussed, in that case everything will change. So in that case, this one will be B, this one will be A, this one will be A, this one will be B, and this one will be A. Clear? If I am changing this one will be the answer. So that is why I am telling, whenever such graph will be, this is board question, and when such graphs will be given, you see that one, what it is given, and what in x-axis and y-axis. So next is superconductor. Superconductor is a substance of zero resistance. So here superconductor, it means that obviously it seems conductance is more. So how this conductance will be more? if resistance will be less. So here superconductor means it should have zero resistance. Some books it is also written it is of negligible resistance. It is zero resistance means infinite conductance at very low temperature. Okay, so this is 2020 board question. This is 2020 board question. Here, what is superconductor? That was the question. So, superconductor is a substance of zero resistance or infinite conductance at very low temperature. So, here example when this question will be given and will be asked, write an example for it. You don't go for only mercury or lead. You have to mention the temperature, because at ordinary temperature this mercury and lead, they do not act as a superconductor. So here at very low temperature, just like below 4.2 Kelvin and below here this lead below 7.25 Kelvin, they act as a superconductor. One thing it is, when we go for the low temperature decreases. At that time the vibration or kinetic energy of the molecule decreases. So when kinetic energy of the molecule decreases, that time there will be very less substances which offer this resistance to the flow of electron, or it is negligible resistance or zero resistance to the flow of electrons. Okay, so that is why there will be, these are at very low temperature known as superconductors, and these superconductors, these are not commonly used, because to get such temperature it is very difficult to achieve such a low temperature. Okay, so when we are taking a wire, they can be of different material. So while using this, while choosing a wire of different material, let us see different purposes. What are the different type of material we choose? So first one, it is electrical connection. Let it be house wiring, or let it be power transmission. So what type of material of the wire should be used? So in these cases, that wire should possess least possible resistance. They should possess least possible resistance. So when resistance will be less, so conductance will be more. So here in this case, the current in that entire circuit will be remain unaffected, because one thing remember, this resistance increases with increase in the length. Now entirely household circuit we are taking, otherwise we consider that one for the power transmission for a long distance to go. Here in this case resistance should be less. So resistance should be less means conductance should be more, and here the current in the entire circuit will remain unaffected. Understand? And due to this heat energy whatever it should release, so one formula for it there, H equal to I square RT. Okay, this is one formula. Next chapter we will read this. So H equal to I square RT. More will be this R is for I for current, R is resistance, T for time. So more will be resistance, more heat will be generated, and this one T will be time period will be more, and heat generated will be more. So to avoid loss of energy due to heating, it is prevented, because this resistance remain constant and current it is unaffected. So what is this household wiring? This can be of aluminum, copper and this, but one important thing is that this silver is also, the specific resistance of silver is also less than copper or aluminum, but due to its high cost, this silver is not used, rather aluminum and copper is used. Okay, second one, it is filament of the electric bulb. So electric bulb, why it is taken, what is the material used? Tungsten is the material used. Okay, and here why the tungsten? Because tungsten has this high melting point. For long time bulb has to glow, no? So current have to pass through it. It has the high melting point. Here I square RT also I told, H equal to I square RT previously, time period will be more. So more heat will be generated. So more heat will be generated means, if we will take low melting point, so that this wire will there will be cut, or you can say that there will be a disconnection between the wires may melt. That is why high melting point wires are taken. Then fuse wire. Fuse wire, it is the this is the alloy of This is the fused wire, this is the alloy of lead and tin. Why it is the alloy of lead and tin taken? Because in this case, this fused wire should have this low melting point and it should have this high resistance. Resistance will be high, means temperature will be more will be temperature. Then this one, as it has the melting point low, that is why the fuse will blow off and it will have the safe to the circuit. And here standard resistor, any resistor we are taking, it should be of high resistance. And one important thing, that this resistance must not change, this resistance must not change due to the change in temperature. So temperature changes, then this resistance also changes. Temperature changes, resistance also changes. But it should be in such a way that this material resistance will change, sorry, temperature will change, but resistance will not change. You remember, not when we are standard 9, you have seen that rheostat, and rheostat, some wires are on, so that wires are made up of Constantian. Why, what for it was taken? So teachers must have told you this Constantian wire for this purpose only. They have a high resistance and they remain unaffected with the change in the temperature. Because when current flows, there will be rise in temperature. So to avoid that one only, here manganese or Constantian is taken as the this material. Then heating element. What should be the heating element? Heating element means let it be heater, toaster or oven. Whatever this wire we are taking, that is made up of nichrome. Why it is made up of nichrome? Nichrome has high specific resistance. More will be resistance, it will provide more temperature. So resistance increases to a great extent with increase in temperature. That is why only this heating element will be made up of nichrome. So itself known as resistors. So now we will discuss the combination of resistors. Combination of resistors. So when these combinations are taken, these combinations are of two types. One will be series connection. One will be series connection. Another one will be parallel connection. One will be series connection. Another one will be parallel connection. Now let us see what is series connection and what is parallel connection. Okay, so in case of series connection, what it can be? Let it be this one. Okay, so we can say this one is, let it be R1, let it be R2, let it be R3. Current flows from this side, pass through R1, then goes to R2, then goes to R3, then comes to the again to the cell. Okay, what is parallel connection? In case of parallel connection, this one will be parallel connection. Okay, this one will be R1, this one will be R2, this one will be R3. Clear? So, in case of series connection, this one it is end to end connection. End to end connection. This one is end to end connection. One positive connected to one negative terminal. Again negative terminal connected to the positive terminal. Okay, if current flows through it, this side will be positive, this one will be negative, this one will be positive, this one will be negative, positive, negative. Like this, these connections are made. But in case of parallel connection, what it is? In case of parallel connection, they have common positive and negative terminal. So here R1, this one will be positive, all this one will be positive, positive, this one will be negative, negative, negative. So they have the same common positive terminal, common negative terminal. Clear? So another part is that whenever current flows through it, current remains constant. Here in this case, I is constant. Through entirely circuit, I will be constant. But in this case, as those are connected to the same cell, that is why this one it is they have the V constant, potential difference constant. They have the potential difference constant. Clear? Then what else will be? Here in this case, if I connect this one, current flows, this is just like a junction only. One current goes this side, one current goes this side, one current goes this side. So let me classify this one I1, this one will be I2, this one will be I3. Again when it comes, there will be I and it comes. But when in case of series it comes, it will be I and I. Through this all the resistor, all this one, this current will be same current flows. Here, this potential difference will be different. Here, potential electric potential is different. Here, I is different. Clear? Electric potential is different and I is different. Okay, now let us go for something else. Let me rub this one so that we can discuss. So here in this case, what we are getting here, this one will be V1, this one will be V2, this one will be V3, but this one will be V only. So what we are getting, V equal to V1 plus V2 plus V3. But in case of parallel combination, I equal to I1 plus I2 plus I3 and goes on. More resistors will be there, accordingly it will change. Clear? Then if we will go for it. Now we know B equal to IR formula. B equal to IR. So here as current will be same, so here V equal to IR is equal to I R1 plus I R2 plus I R3 goes on. Yes. Then what it can be? I R equal to I will take as common R1 plus R2 plus R3. This one will continue like this. Then this I will cancel. So R equal to R1 plus R2 plus R3 goes on. So what will be the effective resistance in a series? The effective resistance in a series is R1 plus R2 plus R3. How many resistors are there? It goes on like that. Clear? Then let us go for this say parallel connection. But we know V equal to IR. Clear? So I equal to how much? V equal to IR. I equal to how much? V by R. Clear? So I can write V equal to I equal to V by R. So I can write V by R equal to here V by R1, V by R2, because B remains constant. That is why it can be like this. Clear? Then it can be V can be taken common. So V can be taken common and it can cancel. So 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3, it goes on. So effective resistance in case of series parallel connection will be 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 and it goes on. Clear? So one important thing is here effective resistance is more. Here effective resistance is more. Here effective resistance is less. This is the reason only why whenever there is a connection household circuit, this connection it is made in the parallel, so that whatever these appliances are connected, those every appliances will be connected with the same potential difference or same voltage. Clear? So this is about the combination of resistor, and also it is not that one only this parallel or it will be series connection. This can be also a combination of both parallel and series. Okay, so here it can be this also can be. Okay, now let us solve this. Let it be A, let it be B. This is 2 ohm, this is 2 ohm, this is 2 ohm. So effective resistance across A and B, let us find out. So first of all, it is parallel connection is there. That is why what it can be, 1 by Rp equal to 1 by 2 plus 1 by 2. So this one will be 1 by 1, 2 by 2 equal to 1. It implies R equal to 1 ohm. So effective resistance R equal to 2 plus 1. This one will be 3 ohm. So effective resistance through AB, that one will be 3 ohm. Okay, so this is all about this series and parallel combination. Okay, so every time one numerical comes here, you practice this numerical, many numerical comes in the board also. 2 mark question, this is section A.